Okay, so we're here today to answer the question of how much aluminum is in this jar. Okay, there's some, you can see. Now, to help us to do that, I have some tools. I have a balance here. This is a centigram balance, which means it measures to 1/100th of a gram. Okay. Got a couple little cups that we can weigh things in. I have a couple of empty jars. Okay. And a big jar of aluminum. Looks like that. Okay. So here's what I'm thinking I'm going to do. I'm going to start with my scale here. And grab a little note card to take some notes on. So I'm going to start with my scale. I'm going to turn it on. Notice I've got a tray on it already, so when I turn it on, it'll calibrate so that the tray is already included there. It's never a good idea to weigh anything directly on the pan of a balance. You should always use a container of some kind, okay? You know, if it's just these little pieces of aluminum like this, maybe it's not a big deal, but if it's a powder, you can get the powder down inside the mechanism and then your balance becomes a paperweight. If it's a liquid, of course, it's even worse. So I see this now, this is calibrated at 0. I'm going to take this full, well, I'm not going to weigh this yet. I'm going to weigh an empty one first, okay? So I have an empty one. These are baby food containers from long gone by. And you see I've got a couple of them that look very similar to the one that's got the stuff in it. So I'm going to take this empty baby food container with the lid, put it on there, and I read a mass of 89.78 grams. Maybe write that number down. So empty jar 1. Oh, 89, let's call it 89.80 grams. Okay. Empty jar 2. Fine. So empty jar 2, again with lid, put it on there. And I get 89.15 grams. So pretty similar. 89.80, 89.15, pretty close. Okay, so that's our 2 empty jars. Okay. I'm also going to take some aluminum and I'm going to do the whole counting by weighing thing. Okay. In your lecture slides, there's a discussion of how this works. I've got some pieces of aluminum shot that I've, inadvertently, and now advertently spilled on the table here. I'm going to count out 25 pieces. Okay. And in those 25 pieces, I'm going to figure out what the mass is. Now, what if I get things like this? I've got a piece here, and camera, maybe you can see that. It looks like 2 pieces stuck together. Okay, I'm going to count it as 2 pieces. Okay, so let me count out 25 pieces. So I got 2, 3, 4, 5, 7, 8, 9, 10, 12, 13, 14, 15. This is 3 pieces stuck together, so that's 18, 19, 20, 1, 2, 3, 4, 5. 25 pieces, okay? I've got my tray here, and rather than weigh the tray, I'm just going to put it on here and then hit the 0 button. This is a process called taring, T-A-R-I-N-G. Okay, do that. And now it registers as 0 with this cup. So if I take the cup off, now it measures as a negative mass, but I'm going to take those 25 aluminum pieces, put them in this tray. So I'm going to take another record here. So 25 aluminum pieces, sample 1. I got 12.31 grams. Okay, put this off to the side. Put the other cup on here, tear that one as well. Now that's at 0. Let's count out 25 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. 25 more pieces. Okay? And those pieces into this cup. And we'll weigh that cup. So 25 aluminum pieces, sample number 2. I get, looks like 11.92 grams. Okay, a little different than the first, but I mean the pieces are not uniform size, so a little bit of variation might be expected. Maybe we should do a third sample. And do a third sample. Okay. I'm going to reuse the first cup. I can do that. I just again need to tear it. So let's do 25 more sample pieces. Well, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. So put that on there. 25 aluminum pieces. Sample number 3. I get 12.96. Okay. So quite a bit more. Okay. We got 3 samples. I think that's probably enough variety to account for the fact that there's, the pieces are not all uniform size. Some are bigger, some are small, some are stuck together, blah, blah, blah. Okay. Last thing to do then is let's take the full jar. And again, let's set it so that it's at 0. So full jar. With that. And I see 159.52 grams. Okay. That's really all the data you need in order to be able to solve this thing. So what I will do in just a bit here is I will post this information in the assignment page on Canvas. It will be up to you then to come up with what you're going to do in terms of processing it and making it into something. Okay? Questions? Yes. So the amount of gas inside the bottle is probably on the order of 50 to 100 milliliters. Gases typically have densities that are in the range of 0.1 grams per cubic meter. So there is some gas in there, but the difference in the amount of gas is not going to be enough that this scale will be able to measure it. Okay. It is, as the saying goes, beyond the resolution of this instrument. That makes sense? Okay. Other questions? Other thoughts? Okay. let me say goodbye to our distance learners. I'll post this on Canvas. You should see it in just a few moments.